Hello and welcome back to the lab. Today on the bench, we have a couple things that I've ordered, and I'm going to need to address an issue that I've had with the bench itself for some future projects. I'm going to be working on some projects where I'm going to have to really up the sensitivity of the components is getting a lot higher, and I have to take some precautions now. In this video, we're going to do an upgrade to the bench itself, and I'm going to talk about a few things as to why I've done the things that I've done and go from there. So if that seems entertaining, stick around because we're going to get into it. So first things first, let me move the camera up just a little bit and I will talk about this mat. So this mat is an anti-static mat that I've had in all of my videos since the beginning, but the astute who have watched the videos for a while will know it has never been hooked up. So this has never been grounded in any of the videos prior to this. Now, the reason for that, or there's a couple reasons for that, is I haven't been too concerned about static in the lab because I handle it in different ways. One of the ways that I handle static electricity in the lab is I keep a very close eye on the humidity of the lab. For doing some of the environmental monitoring, I use AirThings units. They're very much like smoke detectors. You can wave your hand over it and it'll give you a just LED readout of what's going on in the lab. This is the Wave Plus unit. It reads a lot more than the standard AirThings module because it also gives me CO2 levels of the lab, barometric pressure, and VOCs, where the base unit only gives you humidity, temperature, and, in this case, radon. I live in an area where radon is a concern, so I do some monitoring on it. Here's actually what the app looks like. Yes, it is an Internet of Things device. However, it does not have an IP address, and this is not on my Wi-Fi. It uses the phone to sync. It syncs Bluetooth with these, and then it goes up to the cloud through the phone. So what we've got is we've got radon and things like that, but it also gives me history. So if I click on humidity, I can get 48 hours, week, month, and year for average humidity in the lab. 42% or 40% is about the lowest I want to get before I turn on the humidifiers. I want to keep it between 40 and 60. Over 60, I'll start having condensation problems. Below 40, I start having, I start drying out, which is uncomfortable, but I also start having some static problems as well. Currently, in the lab, we're at 48. Very happy. Also, this is nice around computer server rooms. So computer server rooms are 72 degrees, 50% relative humidity, as close to that as possible. Everything is good. I'm going to put this back up on the wall. It actually has a plate and there's a magnet here. It just sticks on the wall magnetically, and I have some rechargeable batteries in there. Runs on 2 AA's. The 2 AA's on this run about probably 8 months or so. I have a couple of these around the building, and for monitoring the air quality, I especially like the VOC and the CO2 monitoring down here. Some might say monitoring the air that close in the lab is a little bit of an overkill, but there is a wood-burning stove for heat in the wintertime, and nothing dries out the air faster than that wood stove. Before I was having a horrendous problem with static, and also my hands and everything were cracking, and it was awful. And I turned on a humidity meter, and with the stove going in the dead of winter, I was at like 5% relative humidity, which is not good at all. Also, the humidity level here, it eats. Are they 1.5 or 2.5 gallon tanks? I'll get one of the tanks here real quick. But the humidifier can eat both tanks of water in a day. So the stove really dries the air out, so it is a concern. So this is one of the water tanks that goes on the humidifier for scale. My hands are not small. I do not remember if this is a 1.5 or a 2.5 gallon tank, but there's 2 of them on the back of the humidifier. It's a wick-based humidifier, and it will go through both of these tanks in a 24-hour period to keep the air at about 40% when we're hitting the wood stove pretty hard. The humidifier itself is rated for a 2,000 square foot house, and it is only being used to humidify the lab. It's not really doing much anywhere outside of it, just because the lab air is being dried out so quickly. So definitely want to keep this. This is one of the main ways we keep static under control here in the lab, especially in the wintertime when things get really dry. If there's interest in the humidifiers and some of the air treatments we've done in the lab and the structure as a whole, let me know, and I can go a little bit deeper into the hows and whys of that and go to it. One of the short answers is the water where I am at is the hardest water I have ever run into. I might as well be showering with boulders. It's really, really hard water. The ultrasonic humidifiers, the calcium just builds up on those and kills them in short order. The wick-based ones don't necessarily have as much of a problem with that. But so there are some reasons behind the choices that were made. That gets me into these boxes. So what are we going to do, and what do we need to do? Well, I'm going to be working on some sensitive projects coming up, and I need to figure out the ground solution for the lab. So we have a couple of things we're going to use, and we're going to really up the ground solution on the bench. Now, why has it not been hooked up in the first place? One is I wasn't too concerned with the ground at this moment in time. The second reason it wasn't hooked up is, especially when I'm working on scopes and things like that, this is a true anti-static mat, so the top part is, quote, non-conductive. The bottom part is conductive, and it's supposed to bleed off the entire mat into this point right here. Obviously, if the bottom part wasn't conductive, you wouldn't bleed charge from way over here to all the way up there where the connection is that goes through to the bottom layer. So these mats are an interesting material just given their properties, but I also have open on the bench 4,000 volt supplies, 25 kV supplies. I do a lot of things with high voltage. So even though this has some decent resistance to it, pardon the dust, it's old, it was still, I was still nervous about some of those extreme voltage supplies shorting out to the mat and running back to ground. So I haven't had it hooked up. It's been used as a mat, and that's about what it's been used for. There's a couple of things around that, and we're going to get into some of that today. But first things first, we have a grounding plug. So I am going to get a better grounding solution than this eventually. I don't have time to poke holes in the wall, run a true grounding strap to a ground rod out back, sink a couple of ground rods, make a really solid ground connection. We will do that at some point. I just do not have time for that right now. So I am going to be using the ground pin through the electric panel, which is bonded to a ground rod out front, outside, and is good to go there. So we also have this. And part of the reason for this is I have long ago lost the cord for the mat. So this should have a cord. This was supposed to have a cord with a snap on it. It does. So in theory, this snap should fit this snap. It does. So we are good there. And one of the other tricks with these ground clips is you can pull the alligator clip off and get a 4mm banana plug. Now, theoretically, an easy way to do this is to just pop this in here, and we're good to go. But we're going to do something a little different, because I also am going to be doing board assembly, so I need to ground some soldering irons too. Now, The Heiko iron that I have is grounded through the tip, but I'm also going to ground the holders, the brass brushes, and a few other things in it, and we're going to go into that a little bit later. So I also have this connector, and we're going to test this because there's a reason I picked this one up thinking it would work, and then I thought about it for a little bit, and this might have a flaw in it that I want to talk about. I know this one will work and doesn't have the flaw that I'm worried about. So on the other box, we have a nice big bus bar. So what I'm going to do is I'm going to wire the ground point to this bus bar. This bus bar is then going to distribute ground around the bench, not to be confused with some of my, pardon the camera movement, some of my ungrounded power strips for safety reasons. We're going to have a ground distribution point where I can get everything into the bonded mains and get those safely back to earth. So let's hook up a ohm meter to this and see if this does what I think it's going to do. All right. We have the device. We'll pop this in because those are 4mm banana jacks, so we'll hold it like that. And I'm going to hook this up. And what do we think the meter's going to do? Do we have a problem? Yes, we do. Okay. So, if you were trying to truly ground something, not necessarily manage static, but true grounding, we have a 0.05, so 50 milliohm connection into the 50 milliohm connection through this device. Well, is that a problem? Yes and no. Depends on the goal. This is too solid a connection to ground that I don't want a dead short to ground for static control. So we'll get the other one. Now I'm really happy I bought this one because I know this one's going to have what it needs. That one I was concerned about. There we go. So through this plug, if I can get this lead to stay on, we have a 1 megohm safety resistor that is actually a true safety resistor to ground. So instead of being a dead short, this will just bleed off like it's supposed to. And if we take a look at this, it's a Kumol, but it says ESD use with 10 to the 6 ohms resistance to ground. This is what I actually wanted. So what I'm going to do is I'm going to take this unit, plug this into the wall. We're going to come out of it into the distribution block, into the devices on the bench to let me bleed charges off slowly, but not create a dead short to ground. The problem is if I have something up here that has a static charge on it and I set it on the mat, now all of a sudden it'll short to ground. That could damage something and things like that, especially if I'm working on high voltage supplies. This puts me a megohm above ground and will bleed charge off slowly, preventing damage to sensitive components. So, good ground connection, but no good for my purposes. Bad ground connection, but exactly what I'm hoping for my purposes. Bleed off charge versus dead short charge. So if you get some of these, check to make sure they have the resistor in them, or no, you have a dead short to ground. That could be a problem if you have a high voltage supply on top of this mat and you have a path to ground and you don't have an isolated supply. Now all of a sudden you have a way for the power supply to bleed off through the mat to ground, and it could short the supply out and do some damage. So take care. I should also say, for liability reasons, if you do not feel comfortable doing anything that is shown in these videos, I have been doing this for a very, very long time, and I am comfortable working on elevated voltages, and I know a lot of the procedures and gotchas that come with doing that. So if you do not feel comfortable duplicating anything that you see in these videos and you don't understand what's going on in these videos, ask a ton of questions, get help. Do not take this stuff. Don't just run with it. especially working with high elevated voltages, can be fatal. Please use extreme caution. Had to go to the longer term storage to find unshrouded banana connectors. So, let's see what we've got in the box of connectors. Small banana, not 4. That's red. Hopefully I can get a negative. I doubt I'll find green, but I would like... this will probably work, yeah. Oh, wait, that is green. Haha, it's just an old green. Okay, so we have a ground lead. Perfect. Now, I'm going to go charge the air compressor to get the absolute best solder joint we can. We're going to do this under nitrogen. And yes, I do understand the irony about talking about good solid connections and then lifting it a mega ohm above ground. That is not lost on me at all. However, as I am building up the, spinning up the N2 iron, for those that don't know, we have a nitrogen shield gas soldering iron here in the lab. I do have to change this. So this is the carbon filter that comes out that is in the airline. If you have questions, I'll leave a link in the description below to the airline video of where I talked about putting these in. The N2 filter strips out the oxygen, leaves the nitrogen, dumps the oxygen into the room, and pumps the hot nitrogen through the pumps the nitrogen concentration through the iron to get hot, because it passes the heating element and then comes out as hot N2. These charcoal canisters are a final solvent gas trap in the airline to protect the N2 filter, which is horrendously expensive. But these are only good for about 3 months. So every 3 months, depending on use, you have to change this out. You should see no water or any vapor left in here. This is to take out the solvents, things like that, because the N2 filter is sensitive to solvents and things like that. So given that my air compressor is in the dirty side of the building, I took a lot of precautions cleaning up the air before it hits the bench. Now, all the bench air goes through all the filtration. So when I'm using the air gun on the bench, things like that, all of that comes through this filter as well. All the other filtering, there's actually 2 3-stage air filters. Or no, I'm sorry, there's a 3-stage and then there's a 4-stage before it gets over to the bench. So I'm gonna get this swapped out real fast. Not a big deal. It's just take the case off, pop this in, put the case back on, and everything's good to go. But that is just a maintenance item. If you're going to do the air filtration, this needs to be changed periodically. Okay, now this N2 iron is total overkill, but we have it, so we're going to use it. So if you take a look, you can see... Oh. Can we see? Oh, nope, I'm paying attention to the screen. See how the flux fumes are shooting away from me? That is not the fume extractor doing its job. That is the N2 shield gas shooting out from the iron. Complete overkill for this job. We have it, so we're going to use it. However, the N2 does have a purpose in the lab, and I really put it in to start working on the Tektronix ceramic strip units. It really makes the I'm paying attention, not getting burned, so I'm trying to talk while I'm soldering, and that's not a good idea. It really makes the lead-free solder behave better when I'm doing ceramic strip soldering. But we're already off. The other thing that the N2 really does when doing surface mount work is it does act as a preheat for the board, and can make things just behave a little bit nicer. Did fire up the gun too. Our solder plug has a little bit of a hole in it we're going to need to clear, but that won't be too terrible. While I wait for the FR410 to warm up, this little ball, this is how much nitrogen is flowing through the tip of that iron. It's 1.5 liters per minute. I can turn the gas off with this valve here. And it'll go down, and then we can work around the camera here. This is tight. We can open the gas back up, and it comes back up. So I do not need it hooked up to gas bottles. The other thing to be cautious of if you're going to set something like this up in an enclosed space is you can get nitrogen asphyxiation by just dumping gas bottles into the environment. It can displace the oxygen, and you can pass out and suffocate. The oxygen that is in the shop air is being dumped into the room, so my room mix of gases isn't changing. However, that would not be the case if I had this hooked up to bottles. It was one of the other reasons I set the system up this way, regardless of the cost. Okay, we're just gonna see if we can clear the pin real quick. Nope, so we're gonna have to warm this up. I just use the other iron to preheat this real fast and get some fresh solder on there to make this easier. Now we will hit this, let this melt, get some heat on it. There we go, that sounded good. Hey, look, we're clear. Awesome. Now, I am not going to touch this. This is going to be lava for a while. So we're going to set this right here on some metal. Actually, let me clean off this bottom side while I got the brass hot. I'm trying to do this around the camera and get this on camera, so I apologize. All right. Here's our remnant that came out. What we're going to use instead is I have some green silicone, very nice silicone, but safety rated. You can see the white in there, I think. Camera's picking that up. There's a white core, so if you fold this or move this around and you see that white core start to show up, that means the wire's degrading and needs to be replaced. This is the same thing they use in higher-end meter leads. So we're going to use some of this to put our BNC on, or BNC, banana plug. I swear I can talk today. Now, another place where the N2 iron is going to make it a little nicer to solder this is I can come down in the top, and that shield gas is going to go through the connector, so it's going to help preheat the wire towards the bottom so I don't get a cold joint. And I am going to really let this warm up. Now, because this is just wire, we have a silicone meter lead and brass fitting, I am dumping a lot of heat in here. This is a really long dwell time for a soldering event. So, especially on a board or something like that, I'd be roasting the board at this point. So, this connection itself is very tolerant of high heat, where something else may or may not be. So I shaped the tip a little bit. Now I'm going to let that cool for a while because I did see I do not want to touch this, even though I got my finger close. That is very warm. However, you will notice the Heiko iron, my other iron would have done the same thing, but I used a small tip, and I have it set at 650F, and it just dumped. Now, I do have it set on the 140-watt side, but it just dumped heat into this brass fitting. So, no, that's cooled off. So now we'll do just a tug test. Oh, that's good and solid. All right, cool. So, now if we didn't destroy the threads too much with solder, let's see what happens. Yeah, it'll go. I'll need to get some tools, and I'm going to get a little bit of contact cleaner. So, how'd we do? Holding the threads. Have our socket here. And let's just screw that in. And that is working. That looks really, really good. Get some bigger tools to get that tight, but I am quite happy with that. Sorry, I am reaching around the camera like crazy. There we go. So now our green barrel, which I did not forget to put on, screws in like that. And then this will go into the wall, and that will go right there. But that was fairly loose, and as this is a safety connection, where's a flat blade screwdriver? Little one, tiny one. There we go. I'm going to come in here to these banana blades and pop them up a little bit, get a better contact. We're also going to put some contact cleaner on here. We're going to get a really good contact on this connection, even though it's a mega ohm above ground. I want good, solid connection. Okay, as we can see, testing through the entire bundle of green cable, 0.986, that's through our new banana jack, and everything's good to go, and onto the ground pin of the yellow plug. So now I have to figure out exactly where I want to put my bus bar. So where do I want to set the ground for the bench? I don't know yet. Probably underneath. Okay, one other trick for people who may not have seen one of these before. We have a crimp tool, but we have a crimp tool with changeable dies. These can be highly useful depending on the thousands of different cable types you may need to put together. Right now I've got it set up for the two standard F and B and C connections. However, this front one is actually for RJ45 Cat5 jacks for computer data networking. But we'll flip this over to be able to do ring terminals just by popping the two screws out. Pulling out those dies, putting in these dies. Yes, I put that in the right way, I think. I let the dies settle. It is possible to jam one of these frames if you put the dies in a little bit off, because they have some clearance on the screws. So I crimp it down till it almost pops. So right there, where it's one more click and it's going to open, and then I tighten up the die screws. But now we're good for ring terminals, so we'll set yeah, that is right. Okay. We'll set the ring terminal back here. And because the smaller end is on this side, the connector needs to come out of this side of the crimp tool. Smash it closed, and there we go. Now, let's take a reading. Just make sure we have a good connection. 0.073. That is a nice connection. Pull it, good crimp. So I have to make a bunch more of these. I'm going to be using these eyelet connections to go on the soldering iron, and I will show you guys that here in a moment. Let me get the cable of the appropriate size. All right, so a neat feature on these Heiko stands is this screw right here, which I have a giant solder blob on, which should pop off pretty easy. It does. So you'll notice the strap that comes down into the pad. This is a Heiko 599B. You can buy these separate. These are actually conductive. So if I hook up a meter, 0.5, 0.05 ohms. So we have a conductive surface on here, which is also transferring to the conductive brass that's in the tip cleaner. I'm going to ground this screw to that ground bus that I just created. So what I'm going to have is I'm going to have the base is going to be grounded. When this is sitting in there, this is going to be grounded. The wool's going to be grounded. The soldering iron is also grounded through the iron itself back to earth. So what I'm going to end up having is, as I clean the iron, I'm going to be pulling charge off the tip. The tip is always going to be pulling charge off the tip going back to ground. So I shouldn't build up any static on the tip of the iron at all to help with some of this sensitive soldering that I'm going to be needing to do. So what that's ultimately going to look like is we'll just get a solder is stuck. There it goes. We'll just run this out. And then what we have is the wing, the thread, we have a lock washer, and a washer. So what I'm going to end up doing is I'm going to end up putting our grounding leg in between, like so, in between the washer and the lock washer, so we get a good connection to the iron base. I am also curious if this will sneak out. If I can have this sneak out the back, that would be nice. Maybe. Oh, yes, the tip. Yeah, that'll probably work for the two heavier irons, but I don't know about the... No, I'm going to run on the outside. There's a lot of solder splash in there from just over time using the irons since the last time I cleaned it out. So I'm actually going to run it down the side like so. So now we have a very solid ground connection right at the tip cleaner basket. Yes, I'm doing this with the iron that is off, so I'm not melting my bench while I have this on camera. So we have the wool to clean the iron tip. This is going to be grounded. The iron's grounded. Everything's grounded. So when I'm working on these JFETs, it's always a concern, but I should have less of a problem zapping the gate. I'm also going to be grounding the soldering iron fixture while I'm working on these, things like that. So I'm taking some extreme cautions with this particular project to eliminate the static problem in the lab. So lots of layers of defense. Shouldn't have a problem, but here we go. I have to do this 3 more times. Okay, as we can see, we have the 2 ground connections all ready to go. I took a meter and measured from soldering iron tip to brass wool, and I got 2.6K, so perfect. And that looks all well and good. There has to be something going on internally in the iron, maybe through the sensor socket to make it 2.6K as opposed to 1 meg, but we're bleeding off the charges and everything looks good. I ran out of cable. The runs were longer than I thought. To keep the inductance down, I have a short run going from the outlet to the distribution block under the bench, but this is all that's left of that green cable after doing the 2 soldering iron runs. So this will be perfect. I got to get some 4mm sockets. So once I get the 4mm sockets, I can go from snap. I'll get the female socket for the male plug, add this extension, and that'll give me my ground for the mat, and I'll be good to go. So that's it for the day. I got to wait on the mailman yet again and get some parts and things ordered for the lab. So thanks for stopping by and taking a look at the grounding solution for the bench. It should also be noted some of the stuff that I discussed earlier in this video is why the bench is wood and not metal. Wood gives me a lot of flexibility in terms of as an insulator versus having the bench top be conductive. That is another consideration in why the bench is built the way it is. So, as always, I will see everybody in the comments. Thanks for sticking around and taking a look at the grounding the bench video. Videos and topics are discussed can be created off of viewer discussion. This is one of them. Also, thank you to all the Patreons that continue to support the channel and help make this content available to everybody else. There's nothing behind the Patreon paywall. They just help out, and they also assist me in steering the channel when I have things that need to be discussed. So, you can check out the Patreon page. I'll be in the comments, and I look forward to talking to everybody between videos. As always, more is on the way, and I will see everyone in the next video.